So here we are looking at absolute value equations. And I'm sure you'll remember, if I asked you to take the absolute value of 5, you'd give the answer of 5. And likewise, the absolute value of negative 5 has an answer of 5. Why? Because absolute value tells us about the distance from 0. So here's 0, and both negative 5 and 5 are 5 units away from 0. So the absolute value of both of those numbers are 5. So we've got two numbers that effectively give us the same answer. So I want you now to think that we're going to work backwards. And I'm going to be giving you answers to absolute value problems, and you have to tell me effectively what the question was, or what the starting value was. So here I've got what the absolute value of what number is 5. Well, remember up here we just did that. There are two values. There are two numbers, 5 and negative 5, that will give this answer. So this is what we're going to be doing. We're working backwards to discover what was the original number. And we're going to be finding what values of x satisfy this equation. What makes it true. So this is just saying which numbers are 5 units from 0. And we know the two numbers. They were the negative 5 and the 5. So just on the simplest kind of level, if we have the absolute value of x is 3, the numbers that x can be are negative 3 and 3. Because if I plug both of those into that absolute value statement, I will have an answer of 3. So there are two solutions. And the majority of work we're going to be doing is going to have two solutions. If I said that the absolute value of x was 0, what number is 0 distance away from 0? There's only one number, 0. So this is an example of when we have one solution. That when we get down to the expression of just an absolute value and is equal to 0, there is only one number that will satisfy that, and that is 0. And then I want you to think about this situation. The absolute value of x is negative 2. We learned a long time ago that when we just solely have an absolute value expression, we are never going to get a negative answer, because in this context we don't talk about negative distance. It is a positive value only. So here, if you have the absolute value of x is equal to negative 2, there is no solution. There is no value that we can put in here, so this is no solution. So we're going to be coming across two solutions, one solution, no solution. Let's get going. So I've got our first example up here. Absolute value of x added with 2 is equal to 6. How are we going to solve them? Just like in previous equations, we want to isolate the variable term. We want to get it on its own. After we've done that, we're going to anticipate how many solutions we think we're going to get, and then we're going to solve. So here, just like in an equation, I want to get the variable term on its own. I'm going to subtract 2 from both sides. And here you'll notice 4 is positive. We have got the isolated variable term is equal to a positive value. I can expect two solutions, and they would be negative 4 and 4. Moving on to example 2, slightly more complex. 3 times the absolute value of x minus 4 is equal to 20. Well, to get this term on its own, first of all I'm going to add 4 to both sides, equal to 24. Then I'm going to divide out the 3. Absolute value of 8 is equal to 8. Absolute value of x is equal to 8. It's a positive value, so I know I can expect two solutions. And they would be negative 8 and 8. Example number 3. This is a little more, this is different to what we might have seen before. This says the absolute value of x minus 2 is equal to 8. So here the variable term is on its own in the absolute values. But now we've got to think, well, this 8 tells us it's positive, tells us that there are two solutions. So this time we actually have to branch off in two different directions, because there are going to be two solutions. But we've still got some math to do before we can work out what they are. I want you to imagine this in here could equal 8, or it could equal negative 8. So what's behind my fingers has a value of 8 or negative 8. So we need to actually set those two situations up. What if the x minus 2 was equal to 8? add 2 to both sides, x is 10. What if it was equal to the negative 8 that would make that statement true? Well, this time, again, I have to add 2 to both sides, but we add 2 to negative 8. We certainly don't get 6, we get negative 6. So here we've got two numbers that are not kind of related like they are here. One number and its opposite. We've got two very different numbers. So that's really important to remember. If we have kind of an expression within the absolute value bars, you're often going to get two numbers that look very different. Oh, I better make my change there as well. Okay. And then example 4, just more complex again. We've just got more stuff going on. We're going to subtract 5 from both sides first of all. Then I've got my expression within the absolute value bars, but there's nothing going on outside of the absolute value bars. I've isolated the variable term, and now I need to set my two situations going. It might be equal, 4x minus 3 might be equal to the positive 5, solve, 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 x is 2, or it might be equal to the negative 5. Again, solve, 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 better make sure I did it right this time. Divide out by the 4, simplify, negative 1/2. Again, two solutions that don't look particularly related, and that's what you can expect. Then, what happens, you might ask, what does a one solution or a no solution look like? So we've just got one example of each. Again, we're going to isolate, anticipate, and solve. So here's one. Here, obviously, we'd subtract 4 from both sides. And here's where I get to 0. I've got the absolute value expression equal to 0. Only one number will equal 0. Only one thing in that absolute value bars will equal 0. It's when that expression itself is equal to 0. Add 3 to both sides, x is 3. Only one solution makes that true. And then what would a no solution look like? Here's one. So I'm going to subtract 6 from both sides. Well, 4 minus 6 is negative 2. So if there's nothing else going on the outside of these absolute value bars, and there's no more solving to do, I'm stuck with an absolute value equal to negative 2, and that cannot happen. So that's what it looks like when it's a no solution. It's when this value on the right-hand side is negative. And then lastly, what would an application look like? So we're just taking a situation, maybe you are in the QC, the quality control department of a manufacturer, and you make candy. And you're selling bags of candy, and on the bag it says that the weight is 100 grams. Well, you must consider that that would be impossible really to achieve in a situation. So you have a plus or minus. So they have a tolerance of maybe you can go 5 grams above or 5 grams below. And that's acceptable to them. And as a customer, you have to take on that, take on the chance that you might get a couple grams below. So they've got the situation where it must not be more than 5 grams below or 5 grams above the advertised weight. And my question to you is, what is the minimum weight and what's the maximum weight? Well, it doesn't take much to just think of a number line and know, well, if I go 5 grams below, it might weigh 95 grams. And if I go 5 grams below, it might weigh 105 grams. So not a difficult situation to work out, just kind of logically. The minimum weight is 95, the maximum is 105. In the QC department, you might be weighing every 100 bag, you might weigh it, make sure it falls within those two minimum and maximum values. But what does it look like if we had a more complex problem? What does setting up an absolute value equation look like? Why is it an absolute value equation for a start? Why is this type? Because the allowance, the plus or minus, is allowed in either direction. So that's why it's an absolute value, because we can have a difference to the left or to the right, and it doesn't bother us which way around it goes. So that's why it's absolute value. And the way you would set this up is, in your absolute value bars, you would have the x. This is the number that you're solving for. You're going to get two values, a min and a max. This is our x. What is my min and what is my max? From that, you will subtract your stated value. It might be your advertised value or your desired value, the weight you're trying to get or the size you're trying to get. This is your goal. And that absolute value statement has to be equal to the accuracy you will allow. So if I subtract my stated value from my min-max value, it has to be within this allowance. So in my situation here, the min and max values, subtract the advertised weight of 100, has to be 5. It can be 5 above or 5 below. That's why we've got the absolute value bars, because that's going to get rid of that negative number that we might have. If I solve that absolute value equation, I'm going to do it in two ways. I'm going to set it equal to the positive 5. X minus 100 is 5, therefore x is 105. And I'm going to set it to the negative 5. What if my difference is the other direction? And that equals 95. So algebraically you can see how to achieve it. But something as straightforward as this, you can just think about it, or maybe do a sketch to get there. But this is an important setup to remember if you've got some other word problem that's maybe not so easy to do in your head. So there we have it, absolute value equations. How to solve them, what they look like in an application. Okay?